All right. The way things are going, I think this is going to be an unlisted video, actually private video, where I'm putting together information for my next vid. And I have to take this and put it into my own words, as much as I'm going to say. Preprocessor. A preprocessor is an integral part of the C compiler, and its function is to recognize and execute preprocessor instructions. These are special instructions which do not belong to C language, but are a part of software package coming with the compiler. Each preprocessor command starts with $. Prior to program compilation, C compiler activates the preprocessor, which goes through the program in search for these signs. If any encountered, the preprocessor will simply replace them by another text, which, depending on the type of command, can be a file, contents, or just a short sequence of characters. Then the process of compilation may start. The preprocessor instructions can be anywhere in the source program and refer only to the part of the program following their appearance up to the end of the program. Preprocessor directive $sign include. Many programs often repeat the same set of commands for several times. In order to speed up the process of writing, these commands and declarations are usually grouped in particular files that can easily be included in the program using this directive. To be more precise, the $sign include command imports text from another document, no matter what it is, commands, comments, etc., into the program. Preprocessor directive $sign define. The $sign define command provides macro expansion by replacing identifiers in the program by their values. $sign define symbol sequence of characters. Example, $sign define pi 3.14. As the use of any language is not limited to books and magazines only, this programming language is not closely related to any special type of computers, processors, or operating systems. C language is actually a general-purpose language. However, exactly this fact can cause some problems during operation, as C language slightly varies depending on its application. This could be compared to different dialects of one language. Alright, so the previous information that I just covered, that Mike Rowe $sign define article, is found in this Hubert LCD document X. I put the link here. So moving forward, here is the sample code I had typed out. I still have to check it to make sure it's all typed correctly. That's a long process. But anyway, what shows up is the register TIMER0. I'll have to study this more closely to see if some other registers show up. Not sure yet. So I think I'm going to do a study of TIMER0. So close that. And I typed in TIMER0, into the data sheet, and there are a lot of instances of it. And the first one is in this list of registers. It shows up on page 52, TIMER0, and not only that, but there's a high byte and low byte register. I believe that's what that signifies. And here is my device. And this chart is particularly addressing like the different power saving states, which I'm not even really interested in at this point, but I will cover the paragraph that applies to these charts. So this is 2 pages up on page 50. Just read the first sentence. Most registers are unaffected by a reset. Their status is unknown on power on reset and unchanged by all other resets. So this table, which is the first instance in the datasheet where TIMER0 shows up, is demonstrating what happens on the different reset power modes for power on reset. mClear reset, that might be actually important. And then watchdog timer or interrupt. I guess I should figure out what all these U's mean. But anyway, I'm clicking the wrong one. TMRH, high byte, and low byte. So the next instance, where TMR0 shows up is Table 5.1 on page 64, Special Function Register Map Devices. And I think all this chart shows is the addresses. And so TMR0H and L, these are the addresses, FD7H and FD6H. Then it shows up in this Table 5.2 Register File Summary for TIMER0. Well, that's a different tangent of exploration. But should I be looking up TIMER0 and the subsequent ones, because the TMR0 shows up a lot here? Is this still the same thing? TMR0IE? I don't know. Okay, now this is page 66, a couple pages down. TIMER0 register high byte and low byte. And it says the details are on page 50 and 125. Well, that's helpful. Maybe we should be looking at 125. Okay, so I could go through all of the other 118 examples of TMR0 in the datasheet, scrolling up and down, but I opened up a separate window to page 125, and this seems to get right at the timer module info, and I'm going to read it. Alright, so page 125, TIMER0 module. The TIMER0 module incorporates the following features: software selectable operation as a timer or counter in both 8-bit or 16-bit modes, readable and writable registers, dedicated 8-bit software programmable prescaler, selectable clock source, internal or external, edge select for external clock, interrupt on overflow. The T0CON register, register 11.1, controls all aspects of the module's operation, including the prescale selection. It is both readable and writable. A simplified block diagram of the TIMER0 module in 8-bit mode is shown in Figure 11.1. Figure 11.2 shows a simplified block diagram of the TIMER0 module in 16-bit mode. Register 11.1, T0CON TIMER0 control register. RW1, well, that's pretty much the same, and number 1 means bit is set. TMR0 on, T0 8-bit, T0CS, T0SE, PSA, T0PS2, T0PS1, T0PS0. Bit 7, TMR0 on, TIMER0 on, off, control bit, enables timer with a 1, 0 equals stops TIMER0. T0 8-bit, TIMER0, 8-bit / 16-bit control bit. A 1 equals timer is configured as an 8-bit timer / counter. A 0 equals TIMER0 is configured as a 16-bit timer / counter. Bit 5, T0CS, TIMER0, clock source select bit. 1 equals transition on, T0CK1 pin. What is that? A Google search tells me this is a letter I. Transition on T0CKI pin. A 0 sets this to equal internal instruction cycle clock CLKO. Bit 4, T0SE, TIMER0 source edge select bit. Number 1 equals increment on high to low transition on T0CKI pin. The 0 equals increment on low to high transition on T0CKI pin. Bit 3, PSA, TIMER0, prescaler assignment bit. A 1 equals TIMER0 prescaler is not assigned. TIMER0 clock input bypasses prescaler. 0 equals TIMER0 prescaler is assigned. TIMER0 clock input comes from prescaler output. Bits 2 to 0, T0PS2, T0PS0, TIMER0 prescaler select bits. So there's different configurations of the prescaler value. 1 to 256, 1 to 2. Okay, that probably covers all of the different bits as a summary. And then I move down to page, really I guess the data sheet says it's 124. Up here it says it's 126. TIMER0 operation. TIMER0 can operate as either a timer or a counter. The mode is selected with T0CS bit, T0CON, pointy brackets 5. In timer mode, T0CS equals 0. The module increments on every clock by default unless a different prescaler value is selected. See section 11.3 prescaler. If the TMR0 register is written to, the increment is inhibited for the following two instruction cycles. The user can work around this by writing an adjusted value to the TIMER0 register. The counter mode is selected by setting the T0CS bit equals 1. In this mode, timer 0 increments either on every rising or falling edge of pin RA4 T0CKI/C1 out. The incrementing edge is determined by the timer 0 source edge select bit T0SE T0CON pointy 4. Clearing this bit selects the rising edge. Restrictions on the external clock input are discussed below. An external clock source can be used to drive timer 0. However, it must meet certain requirements to ensure that the external clock can be synchronized with the internal phase clock, T0CON. There is a delay between synchronization and the onset of incrementing the timer/counter. Okay, there's a block diagram. Here's paragraph 11.1. And so here's a block diagram of timer 0 for figure 11.1. Timer 0 block diagram 8-bit mode. T0CKI pin. It goes to this funny shape. T0SE, T0CS, T0PS2, T0PS0, and PSA. And goes to this thing, and a programmable prescaler, and sync with internal clocks, 2 TCY delay, and then it goes to TIMER0L with these arrows pointing to it, sets TIMER0IF on overflow internal data bus. Note, upon request, timer 0 is enabled in 8-bit mode with clock input from T0KI max prescale. Now I could cover this chart here, but I already don't understand this one, so I'll wait for that to happen later if I need to cover that. Continuing reading, 11.2. Timer 0 reads and writes in 16-bit mode. Well, I will read it, I guess. TIMER0H is not the actual high byte of timer 0 in 16-bit mode. It is actually a buffered version of the real high byte of timer 0, which is not directly readable nor writable. Refer to figure 11.2. TIMER0H is updated with the contents of the high byte of timer 0 during a read of TIMER0L. This provides the ability to read all 16 bits of timer 0 without having to verify that the read of the high and low byte were valid, due to a rollover between successive reads of the high and low byte. Similarly, a write to the high byte of timer 0 must also take place through the TIMER0H buffer register. The high byte is updated with the contents of TIMER0H when a write occurs to TIMER0L. This allows all 16 bits of timer 0 to be updated at once. Well, I wasn't sure if I was going to read this information, but it doesn't go on, and if I read through this, then I'll arrive here, which is registers associated with timer 0. Well, that could be helpful. And then it skips to like a blank page and goes down to timer 1 module, which I don't anticipate reading. Well, I don't know how these timers work, but there is a timer 2 module on like page 133, and a timer 3 module on page 135. And then the next topic is capture compare. As promised, I will read about the prescaler. 11.3. An 8-bit counter is available as a prescaler for the TIMER0 module. The prescaler is not directly readable or writable. Its value is set by the PSA and T0PS2, T0PS0 bits, T0CON 3.0, which determine the prescaler assignment and prescale ratio. Clearing the PSA bit assigns the prescaler to the TIMER0 module. When it is assigned, the prescale values from 1 to 2 through 1 to 256 in power of 2 increments are selectable. When assigned to the TIMER0 module, all instructions writing to the TIMER0 register, example these, clear the prescaler count. Note, writing to TIMER0 when the prescaler is assigned to TIMER0 will clear the prescaler count, but will not change the prescaler assignment. Okay, switching prescaler assignment. The prescaler assignment is fully under software control and can be changed on the fly during program execution. 11.4 TIMER0 interrupt. The TIMER0 interrupt is generated when the TIMER0 register overflows from FFH to 00H in 8-bit mode or from this in 16-bit mode. The overflow sets the TIMER0IF flag bit. The interrupt can be masked by clearing the TIMER0IE bit, int.con 5. Before re-enabling the interrupt, the TIMER0IF bit must be cleared in software by the interrupt service routine. Since TIMER0 is shut down in sleep mode, the TIMER0 interrupt cannot awaken the process from sleep. Okay, timestamp this maybe. Table 11.1, registers associated with TIMER0. TIMER0L, TIMER0 register low byte, TIMER0H, TIMER0 register high byte, int.con, bunch of different letters. And maybe, I don't know, if I didn't cover it here, I might note to self to cover that. Maybe that's the next thing I should look for. T0CON, again, it's got a bunch of other, these two registers might be worth looking at. Trace A, RA7, RA0. So these correspond to all the different bits on port A. Port A 7 to 6 and their direction bits are individually configured as port pins based upon various primary oscillator modes. When disabled, these bits read as 0. Okay, maybe the next avenue to explore is this int.con and T0CON. What are these? I opened up a separate tab and whoops. Okay, int.con. Okay, so it says int.con details are on pages 44 and 111. Thinking I'm going to 111. This page, really it's 49, not 51. This page does feature the int.con registers with different values. Again, dealing with the sleep mode stuff, the power saving stuff. So let's go to page 111. Here is page 111. So I'm already thinking a video that discusses TIMER0 and these int.con. 10.1 int.con registers. The int.con registers are readable and writable registers, which contain various enable, priority, and flag bits. Okay, so I guess a question then is, what are enable, priority, and flag bits? My goodness, those could be separate little word searches in the search. Note, interrupt flag bits are set when an interrupt condition occurs, regardless of the state of its corresponding enable bit or the global interrupt enable bit. User software should ensure the appropriate interrupt flag bits are clear prior to enabling an interrupt. This feature allows for software polling. I won't cover it, but it's got all the different bits and their description. And here's TIMER0, i.e. TMR0 overflow interrupt enable bit. An external interrupt enable bit. Well, that's not. Never mind, I got it confused. I'm looking for TMR stuff. TMR0, IF. TMR0 overflow interrupt flag bit. A 1 is set equals TMR0 register has overflowed, must be cleared in software. Equal 0, TMR0 register did not overflow. I'll leave it at that. But I said, going back to TMR0 content on page 124 thereabouts, it goes into registers associated with TIMER0, and I said I was going to cover the T0CON. So I'll search for it. T0CON. Only 10 instances of it. I'll read this again. Why not? From the TIMER0 module. The T0CON register controls all aspects of the module's operation, including the prescale selection. It is both readable and writable. This chart on this page thereabouts shows the T0CON address. This word search shows T0CON, all the bits, just like a register file summary. And it says go to page 50 and 123. Okay, so I'm on page 50. Again, this page really outlined the power saving modes. And then, well, the mClear reset is in this column. And here is T0CON here. I don't know if that's interesting. Okay, maybe I was getting it confused. This TIMER0 module, which is the thing I'm really investigating, is actually controlled by this T0CON. So now I'm getting confused. Is there a TMR0 register on its own? I guess the registers aren't TMR0 on its own. It's an H or an L in the special function register map. I guess this TMR0IE shows up in the registers associated with data EEPROM memory. This TMR0IE shows up in this INTCON register. I already covered that. And specifically, it's the overflow interrupt enable bit. So the TMR0 interrupt enable bit shows up in this data EEPROM memory. There's also this overflow interrupt flag bit, and that also shows up in the registers associated with data EEPROM memory. Both of those show up in this INTCON here and here, registers associated with program flash memory. TMR0 IP shows up in registers associated with port B, and registers associated with parallel slave port, again TIMER0 Here is like an interrupt logic diagram, and it's showing that the inputs going into this shape. Is that an AND gate? Yes, indeed. I don't know, I think I covered this. INTCON interrupt control register. Yes, it shows up here. It shows up in the INTCON2 interrupt control register. TIMER0 interrupts. Did I read that already? It shows up in registers associated with timer1 as a timer counter, and registers associated with capture compare timer1 and timer3, registers associated with PWM and timer2, registers associated with ECCP1 module and timer1 to timer3, registers associated with SPI operation, registers associated with asynchronous transmission, registers associated with asynchronous reception, registers associated with synchronous master transmission, registers associated with synchronous master reception, registers associated with synchronous slave transmission, and just a guess, the next one will be slave reception. Indeed, I guessed it. Registers associated with AD operation, registers associated with comparator module, registers associated with high-low voltage detect module, registers associated with high-low voltage detect module. I haven't determined if this is I2C or SPI or something else, but timer0 and timer1 external clock timings. Maybe it's neither, and it shows up in the index. What I was basically trying to do is look through this code and just try to find all of the registers that show up in this code. And I think it actually covers it. I think the only register is this TIMER0. I am going to pause the video and just look this over. Okay, thinking out loud. So you scroll down, the actual void main shows up at the bottom, and this is where some other registers do show up, but I think they're ones that I have already explored. Note to self to maybe just type these into the datasheet. I don't know that I've actually studied the ports and the trice in the datasheet yet. I'm not going to cover that one. Yeah, I can't see anything that's something I don't know about yet. So, the next question I ask is if I looked up some sample code aside from this program, and I looked up some code on the 4-bit LCD, what registers does a typical piece of code make use of? Does it use this timer0? Okay, so I'm a little out of order in how I'm going to explain this, or learn it for the first time. Pick 18F4550. This shows up in an LCD programming video. Well, obviously I don't have the SMA version, but even in the description, here's the 4550, and it has a pin count of 40. Here is the datasheet for the 4550, and I've got it here with me, my printout of my 4525, and without going on and on, it's the same pinouts. Almost exactly the same. So, this interfacing 16:2 LCD with PIC microcontroller article that I found makes use of the PIC 18F4550 very similar chip, so maybe I'll try to include this link below as something worth studying or trying or reading. Maybe I should read this and record it. Who knows if I get to that. But I looked immediately with a word search and tried to find like TMR. Nothing. So it does show the code in here. So the TMR register is not showing up. So that answers a question. But it does, in the description, explain a little bit about some of the registers. So it's got the CCP and ECCP. Maybe there's more registers it mentions. I didn't really see a lot of registers mentioned in this code when I read through it. So yeah, I'll try to include this as a link.